This is College Prep Chemistry. This is lesson 1 of the very first unit, and it's the first unit is the longest of the entire class. It's called Foundations, intended to give you the fundamentals of chemistry. And this lesson is on a numbering system, a math system you're going to need to know for chemistry called scientific notation. We'll first start off with a few slides about what is chemistry. So what is chemistry? Chemistry is the study of what everything in the universe is made of and how it is put together. Chemistry studies matter. You can just think of that as stuff, which is anything with volume, meaning it takes up space, and mass, meaning it has weight. Chemistry answers questions such as, why does your skin feel different than a piece of wood? Why is steel solid while water flows? And many other questions. It just deals with everything having to do with why substances are the way they are. Any substance anywhere in the universe. So physics studies energy. Energy does not have volume or mass. When energy comes in contact with matter, it causes the matter to do either A, move from one place to another, that's called translation, vibrate, that's wiggle, or rotate, that's turn. The other thing that energy can do when it comes in contact with matter is change the matter internally, such as taking a different shape or changing its temperature. So energy, if it just moves through space from, say, the sun out into nowhere, then it doesn't have to do anything at all. But we're interested in what does energy do when it comes in contact with matter, because we're interested in the study of matter. So chemistry is interested in energy from the standpoint of its interaction with matter, with stuff, and how it causes it to change. Chemistry is interested in energy when it enters or exits a chemical process. The creation of water from hydrogen and oxygen releases energy. So if you put two hydrogen molecules together with an oxygen molecule, you'll get two water molecules, and that also releases energy. What you're seeing there is called a chemical equation, and we're going to learn about those very shortly. Okay, so the first several days of this course is going to involve math that's used in chemistry. So we're going to kind of hit that early, so you know the math fundamentals that you'll need to deal with chemistry. Chemistry is not all about math, but there is enough, and you're going to want to know how to do it. So the first concept we're going to talk about is a very important one called scientific notation. So scientific notation is a way to convert very large or very small numbers to a shortened length. For example, the speed of light that number is 300 million meters per second, but that's kind of a long number. In scientific notation, it's simply written as 3 times 10 to the 8th power. 10 to the 8th power is 1 million. 3 times that is 3 million. So it's a more compact way to write very large or very small numbers. The parts of a scientific notation number are 3 times 10 to the 8th, though the 3 is called the coefficient, the 10 is called the base, and the 8 is called the exponent. Converting from decimal to scientific notation. So decimal is a term we use just for ordinary numbers as you know them. They don't necessarily have to have a decimal in them. They could be whole numbers, integers, but we're going to just refer to those as decimal numbers versus the scientific notation that we're learning. So 1, move the decimal to form a number between 1 and 9.9999. It can't be 10. It's just between 1 and 9.99. Count the number of places the decimal was moved. And 3, if the original number was greater than 1, the exponent is positive. If it's less than 1, the exponent is negative. So let's just apply those rules to an example here. So note, a negative exponent does not mean a negative number. It is a positive number between 0 and 1. In other words, it's a number less than 1, like 0.02 or something like that. So converting from decimal to scientific notation. So here we have the number 46,700. The comma is for readability only and can be removed. It has no meaning in terms of the value of the number. So place a decimal at the end of the number. So there we place a decimal. You don't see it when you see the number initially, but there it is. That's where the decimal would go, 46,700. Move the decimal to form a number between 1 and 9.999. Count the number of positions the decimal would move. So see if you can do that. How many places would you have to move to find a number between 1 and 9.999? And the answer is you'd have to move it between the 4 and the 6. That would be 4.67. That is a number between 1 and 9.999. So you can see you had to move it 4 places over from where it started. So the decimal was moved 4 places, and the original number is greater than 1. 46,700 is greater than 1, so the exponent is plus 4. So the way you write this in scientific notation is 4.67 times 10 to the 4th power. Now you might ask, what about those 2 zeros at the end? Don't you have to include those? That gets into something called significant figures. We'll talk about that in a few days. But for right now, let's just say that you can leave those off. They're not necessary. Converting from decimal to scientific notation. Okay, now we have a number that's less than 1. It's a positive number, but it's less than 1. It's between 0 and 1. So move the decimal to form a number between 1 and 9.999. Count the number of positions the number was moved. Actually, it should say the decimal was moved. And there you go. You move it from where it was to in between the 8 and the 2. That creates the number 8.2. That is a number between 1 and 9.999. The decimal was moved 3 places, and the original number is less than 1, so the exponent is a negative 3. So you would write that number as 8.2 times 10 to the negative 3rd. So note, a negative exponent does not mean a negative number. It is a positive number between 0 and 1. So converting from scientific notation to decimal now. So there we have a scientific notation number. So you write the coefficient by itself and move the decimal the number of places of the exponent and fill the blank spaces with zeros. So first we're going to write 6.7. You see that it's 10 to the 3rd. So you're going to move the decimal 3 places. Now you might ask, how do you know which way to move it, right or left? Well, 10 to the 3rd is a number greater than 1. It's 1,000. So that means you're going to move the decimal in a direction that's going to make the number bigger, not smaller than 6.7. So we're going to move it to the right. The exponent is positive, so the number will be greater than 1. So there it is, 6,700. In those 2 empty spaces you see in the arrow up above, you place zeros in there, and so you have 6,700. Now, of course, you don't place the decimal point there, but that's where that decimal point would have ended. So the decimal can be eliminated if there are no digits to the right of it. Okay, converting from scientific notation to decimal. Here's another example. So it's 2.1 times 10 to the negative 4th. So the exponent this time is negative. That means it's going to be a number smaller than 1. So write the coefficient by itself and move the decimal the number of places of the exponent and fill the blank spaces with zeros. So we see that the decimal this time is going to move to the left because it's got to be a number smaller than 2.1 or even smaller than 1. So if you move it 4 places, you have those 3 blank spaces where you see the arrow there. So you're going to fill those with zeros, and there we did. So we have 0.00021. The exponent is negative, so the number is between 0 and 1. And there's the number right there. Now, a leading 0 should be placed to the left of the decimal. That's that very first 0 there. It doesn't change the value of the number, but it's always done in science that you put a 0 in front of the decimal place like that if there's no other digits there. Okay, now we're going to do multiplication of scientific notation. So it says multiply the following. So 4.1 times 10 to the 7th times 1.8 times 10 to the negative 2nd. So here's what you do. Multiply the coefficients and add the exponents. So there's 4.1 times 1.8. You'll multiply those two. And then you add the exponents. It's 7 plus negative 2, or you could say that's 7 minus 2. But you're adding them. 7 plus negative 2. So 4.1 times 1.8 is 7.4. And 7 plus negative 2 is positive 5. So the answer is 7.4 times 10 to the 5th. Now, what if you have one that's in scientific notation and one that's in decimal? Multiply the decimal number with the coefficient of the scientific notation number and adjust the exponent if necessary. We'll talk about adjusting the exponent here in just a minute. So 3.6 times 2.3, you just multiply those two, and that gives you 8.3, and then you just leave the base and exponent the same, 10 to the negative 6. But there might have been a decimal adjustment, and we'll talk about that, as I said. Okay, now multiply these two numbers. Now you're going to see the decimal adjustment. So multiply the coefficients and add the exponents. So there we go again, 5.200 times 2.300. And then you're going to say 10 to the third plus 10 to the second, or 3 plus 2 is 5. So that gives you 11.96 times 10 to the fifth. Now, we said that that coefficient has to be a number between 1 and 9.999. 11 is bigger than 9.999, so we're going to have to adjust the decimal. So how do we do that? The decimal must be adjusted in this answer so that the coefficient is a number between 1 and 9.999. So see that up there on the top is the original number, 11.96. We're going to move the decimal over to the left one place to make it 1.196. So now 1.196 is a number between 1 and 9.999. So that's good, but you can't just move the decimal without doing something else, because you've changed the value of the number. So what you do is you increase the exponent by 1. It goes from 10 to the 5th up to 10 to the 6th. So in going from 11.96 to 1.196, you've basically divided 11.96 by 10. 11.96 divided by 10 is 1.196. So what you need to do to offset that, to compensate for that, is to increase the exponent by 10 times. So going from 10 to the 5th to 10 to the 6th is an increase of 10 times. So you divided the coefficients by 10 times, you've multiplied the exponent of 10 times. So those exactly balance out. So the two numbers you see on the screen there are identical in value. 11.96 times 10 to the 5th is equal to 1.196 times 10 to the 6th. Move the decimal to the left on the 11.96, making it 1.196. Then the exponent becomes bigger from 5 to 6. So the way I just phrase it is, you made the coefficient smaller, so you've got to make the exponent bigger. The coefficient has been made smaller by one place, so the exponent must be made bigger by one place. The two numbers above have the same value. If you make the coefficient bigger, then the exponent must be smaller. If the coefficient is made smaller, then the exponent must be made bigger. Now we're going to see about dividing. Divide the following scientific notation numbers. So you divide the coefficients and you subtract the exponents. It's just the opposite of multiplication. So 5.2 times 10 to the 6th divided by 2.5 times 10 to the 2nd. So you divide 5.2 divided by 2.5, and you say 6 minus 2, because it's a division. So that gives you 2.1 times 10 to the 4th. 6 minus 2 is 4. No decimal adjustment is needed because 2.1 is a number between 1 and 9.999. Adding or subtracting scientific notation numbers requires a common base and exponent. So here we have 5.0 times 10 to the 3rd plus 3.7 times 10 to the 4th. You cannot add those numbers as you see them there, because you have a 10 to the 3rd and a 10 to the 4th. You have to have the same base, which is 10, and the same exponent. So we're going to show you how to do that. So a common base and exponent can be created by moving the decimal to the left of the 5, making it 0.5. Then the exponent increases from 3 to 4. So there we took the 5 and we moved the decimal one place to the left. We made it smaller by 10 times. So what we then do to the exponent is we make it bigger by 10 times, or by one place. So that goes from 3 to 4. So you made the coefficient smaller, going from 5 to 0.5. So you got to make the exponent bigger. So it goes from 3 up to 4. So now you have a 10 to the fourth in both of those terms there. So now you can add 3.7 plus 0.5 to get 4.2. So there you see you have the same exponent and base there. And that takes care of that. So this is, it's not hard to do scientific notation. It just takes some practice because you're not used to doing it. So we're going to practice these on this lesson.